We talked previously about, very vaguely, about being able to re-express our data, to straighten out some data, to make it look more symmetric, etc. This is the ladder of powers that is used to straighten scatter plots specifically. So looking at this data, and I'm not going to go into too much detail because, again, this is an intro to statistics course. It's not an in-depth. So if you were doing this in-depth, I would show you exactly how to re-express all of this data. For now, I'm just going to give you the basic idea, which should be plenty for what you will be asked to do in my stat lab. So looking at this line, that's my data, and of course here I've got all of my dots in my scatter plot. So the question is, does this look linear? I've got my R value of 0.8579, but looking at it, it kind of looks a little curvy to me. So I'm going to make a residual plot. So the residual plot, we already talked about how to do that. And when I did that, as I can see, there does appear to be a little bit of a curvy pattern to my residual plot. It kind of goes up and then down and then back up again. So that doesn't make me happy and doesn't make me think that I probably should use a linear model. Well, then I can re-express some data. So the reason that we would re-express data is to make it more symmetric, so we can use mean and standard deviation, which we talked a little bit about previously, to make the spread of several groups more alike in box plots, to make the form of a scatter plot more nearly linear so we can find the correlation, etc. So specifically for scatter plots, we're trying to get all of that scatter that's all curvy to instead make a straight line, so then we can find our regression equation and use our regression equation to make predictions, etc. Here is the ladder of powers. And again, it's not important that you memorize these or know these. I just did this for your reference to come back to. But this is essentially the ladder or the power that you might use depending on what kind of data you're trying to re-express. Now again, these are some instructions on how I would do this in my calculator. We're not going to do that, but this would be my new scatter plot based on, for instance, this was the negative reciprocal data because it's miles per gallon, negative reciprocal, and I can see that it looks a little bit straighter than it did before. So here was the original and here's the new, and the R value before was negative 0.8578. The R value now is negative 0.9188, and remember that's closer to -1, and therefore it's a stronger model. And the stronger the model, the more comfortable I am using it to make predictions, etc. Now when I write my new equation, really the only thing that changed is now I've got, because I did the negative reciprocal 1 over the fuel efficiency, etc., this is how I would write my equation. So in my stat lab, really it's going to be sort of a multiple choice scenario where you're choosing whichever one has the best, makes the new best scatter plot, makes the new best equation, etc.